Hello students, welcome you all. In this video, I am going to solve the next numerical from chapter 11 electricity class 10 science. So the question is, compare the power used in the 2 ohm resistor in each of the following circuits. So here we have two circuits, that is the first one, a 6 volt battery in series with 1 ohm and 2 ohm resistor, and the second one is 4 volt battery in parallel with 12 ohm and 2 ohm resistor. So here we have two circuits. In the first circuit also we have 2 ohm resistor, and in the second circuit also we have 2 ohm resistor, but the first one is connected in series, second one is connected in parallel. We have to find out or compare the power in 2 ohm resistor in the first circuit and the power in 2 ohm resistor in the second circuit. So let's start solving. So I'll write answer. So now what we'll do, we will solve one by one. So I'll write here first one. So here what we have potential difference, or I can write voltage. So what is the voltage given here? That is the symbol I'll write first. So the symbol is V. It is given 6 volt. So I'll write 6 volt. Now you can see here 1 ohm and 2 ohm resistors are connected in series. And whenever it will be in series, we have to find out equivalent resistance. So therefore I'll write here 1 ohm and 2 ohm resistors are in series. Therefore, the equivalent resistance. So in case of series, how to find out the equivalent resistance? Just you have to add the resistance. So therefore, I'll do it here. RS, that is equivalent resistance. In case of series, it is R1 and second one is R2. So consider this is R1. Let me write it with a blue color. Consider this is R1 and this one consider as R2. Now substitute the values. So RS is equals to 1 plus 2 is equals to 3. So I'll write it here itself. I'll make a arrow. RS is equals to 3 ohm. So write on the unit it is ohm. So now we got the equivalent resistance. Now here we can find out the current flowing into this circuit. To find out the current, we are going to use Ohm's law. So I'll write here according to Ohm's law. So you may be thinking why I'm finding the current here, but now you'll understand. So according to Ohm's law, the formula is V is equals to IR, and I want to find out I, therefore I'll do the rearrangement. So I'll get I is equals to V divided by R. Substitute the values. So I will get I is equals to voltage is 6, and just now I got the equivalent resistance, it is 3. To divide it, I'm going to get 2. So 3 1s are 3, 3 2s are 6. So answer is I'll write the arrow here, is equals to 2 ampere. So this is the current we got in this first circuit. Now see here we have to calculate power. And to calculate the power, remember in case of series, the current whatever I have found out just now, this is the current which is flowing in these two resistors. As the resistors are in series, now see here, if I draw the diagram, so this is the first resistor, this is the second resistor. This is 1 ohm, this is 2 ohm. And in this circuit, whatever current is flowing, it is 2 ampere. So the current flowing in these two resistors will remain same. There will be no division in the current because it is a series arrangement, and therefore the current flowing in the first ohm, that 1 ohm, that is also 2 ampere here, and the current flowing through the second, that is 2 ohm, that is also 2 ampere only, and therefore I am going to use the formula of P is equals to IR square to calculate the power. So let me write it here on the other side first, what I just now told everything. So I'll write it here. Here 1 ohm and 2 ohm resistors how they are connected, are in series. Therefore, current in both the resistors will remain same. So remain same means how much? That is 2 ampere. So I write down that is 2 ampere. Therefore, now I'll write, therefore, power is equals to, what is the symbol for power? It is capital P. Power is equals to I square R. Now in this formula, I, just now I told you, it is 2 ampere. And what about the resistance? It is 2, because the question is we have to find out the power in 2 ohm resistor. Now substitute the values. Power is equals to 2 square into 2. So power is equals to 4 into 2. and power is equals to what? 8 and the unit is watt. So this is the power in first circuit. Now we have to calculate the power in second circuit in 2 ohm resistor. Let me solve it on the next page. So the second one, I'll write it here. So as I told, what is the potential difference here? It is 4 volt. So I'll write voltage, symbol is capital V, and here it is 4 volt. And now if you see in this, we have two resistors, this and 2 ohm, this both are connected in parallel. And whenever it will be in parallel, let me draw the diagram. This is first one, this is second one. Imagine this is here R1, that is 12 ohm, and R2 I will take 2 ohm. And here in case of parallel, the voltage will remain same and current will divide. So therefore I am going to use the formula for power calculation is P is equals to V square by R. So see why I am doing this, because in parallel combination voltage will remain constant. This will remain constant in both the resistor. Therefore I am going to use this relation to calculate. So now I'll write the sentence here. Here 12 ohm and 2 ohm resistors are in parallel. Therefore voltage across each resistor in parallel combination remains same. This all sentences I am writing just for you people. You no need to write it in an exam. You can directly just solve. You will get the full marks. So parallel combination remains same. So therefore voltage in 2 ohm resistor, because in question they have told us to ask power in 2 ohm resistor, is 4 volt. So now use the formula of power. Therefore power, that is capital P, is equals to what I told formula, V square by R. So here we have V, just now I told how much it is, 4 volt, and R, what is the resistance, in which resistance we are going to calculate, 2 ohm. So substitute the values. P is equals to 4 square divided by 2. So P is equals to, what is 4 square? 4 4 the 16 divided by 2. So cancel. 2 1 the 2, 2 8 the 16. So I am going to get power, that is 8 watt. So the power in first circuit is also 8 watt and the power in second circuit, it is also 8 watt. So here completes the answer of this question. I hope you will understand the explanation and solution of this question. If you like my videos, share my videos with your friends and consider subscribing my channel. I'm going to solve all the numericals from chapter 11 electricity. Thank you so much.